Well, hello guys, here Mr. G with another video. This time is going to be about the grade 10th, and we're going to work with one of the problematic topics. It's a question on a graph of motion. Alright, this is a question done in previous question papers, and we are going to see how to approach this specific question, and I hope it helps for other questions as well that are similar to this one. But before we continue, don't forget to subscribe for the channel and like the video. The question says the following velocity versus times graph represent the motion of an object that is initially moving eastward. Now that is important. The object is moving east, therefore east is positive, and everything that is on top of the x-axis is east. So this is east direction. All right, and then when you go down here below the x-axis, that will be west direction. That is the first important thing before we even look. So now if we look carefully at this graph, the first thing you must look at as a very important is what type of graph is this in terms of what physical quantities are we speaking about. This is velocity in terms of versus time. Okay, that is the first important thing, and the object have different motion throughout the whole process here. Okay, so that is the graph. Now let's go to the question. They say describe the motion of the object in word for B in the graph. Use the velocity, time, and acceleration in your description. Now, in this case, we are working at B, and they want to know, or they want you to speak about velocity. They want you to speak about acceleration, and they want you to speak about time. So that's all you have to do or speak about for B. Let's move quickly this one out of the way, because I want to use that there to write. Okay, so now what we can speak about the velocity at B. We're speaking about B. You can see that the velocity, first of all, stay constant. It is constant. All right, I can see it because it is a straight line parallel to the t. So it means the velocity does not change. We have the value here, which is 6 constant and equal to 6 meters per second. In what direction? In the east direction. That is the first important thing you speak about the velocity, and all this should be there somehow. Okay, what else about acceleration? If velocity is constant, the acceleration is 0, and that is a very important thing to note. And if you think you are going to forget, you can write a note in which you write when the velocity is constant, the acceleration is 0. What can we speak about this? The time, if you go here, is going to be from 20 to 30, guys, and it means it is 10 seconds. So the time is 10 seconds. So the velocity was constant. The acceleration was 0 for 10 seconds. And that is the question for, or rather the answer for question 7.1. This one was, or this one here was question 7.1. Quite simple. My recommendation, use the graph and describe the motion of the object in each of the different parts there to practice. And you can write a comment to ask a question if you are not clear. Okay, what is the final velocity of the object? Now, velocity is a vector. Remember, and because it is a vector, it needs also a direction. So what is the answer here? This is the final velocity of the whole motion, and if you take this one to the y-axis, which is giving you the values of the velocity, you can see that it's going to be the magnitude 6 meters per second, the negative mean, which is west. So the correct answer is to say 6 meters per second west. If you don't write the west, you don't get the answer. Or alternatively, you can just write minus 6 meters per second. Now, note, you cannot say minus 6 meters per second west, because negative west is east. So be careful, and I hope you understand. I recommend to do it in this way, because because in some places they don't accept the minus. So I recommend the 6 meters per second west. However, negative 6 meters per second means that it is west. Okay, so let's go to question 7.3. Now in this question, they said use the graph and not equation of motion to calculate. So you have to use the graph to calculate the acceleration of the object. Now, remember, in a velocity versus time, the acceleration will be given by, let's just fix that one real fast. I don't like that one there. The acceleration will be given by the gradient, or the gradient will represent the acceleration. That will be the gradient. We have to use the gradient because they say use the graph and not equation of motion. So you cannot go to formulas. Okay, now gradient. Now we have to calculate the gradient for a C. Now C is going to be on this side here. C is this line there up until there. So we're working with C and we have to calculate the gradient for C. Remember, gradient is equal to change in the y-axis divided by the change in the x-axis. So it means it's final y minus initial y divided by final x minus initial x. Alright, and all we have to do is to substitute. Once more, let's move this one out of the way. Let's move it a little bit, there is fine. And then let's do the substitution in here. Final y, it is here. This is final y as well as final x. And then be careful, it is right on the 90. So the final y, you go all the way to the y-axis, and that, guys, is 0. So it's 0 minus initial y is right here, and that will be 6. So initial y is 6. And we go into the x. Final x is 90 and initial x is right here, which is 30. So that is the gradient. When you calculate this one, you will get then minus 0.1 meters per second square. So the answer here is equal to minus 0.1 meters per second square. Remember that minus means that is west. And yes, because the object is decelerating in this case, it means that the acceleration is negative, which is in the opposite direction of motion. Guys, this is the answer for question 7.3.1. That is the answer, and that's it. You can leave it with a negative. It's a vector quantity, therefore the negative must be there is important. Okay? So we can go to question 7.3.2. They say calculate the displacement of the object for A, and note they say always use the graph and not equation of motion. So the displacement is going to be given by the area under the graph. Okay, the area under the graph will be giving you the displacement for that object at A, for the part of the graph at A. So when you coming back to the graph, now A is this first part here on the graph. Now what will the area be? The area will be all this part here below up until the x-axis. This is the area we're speaking about, and the area there is going to be equal to the displacement. Now this area could be a little bit tricky, and that is why we're going to do the following. We're going to divide that one in two parts. Now we have two parts which we know very easy. We have this part here, which is a right angle, and we have this part here, which is a triangle. So if you do calculate both areas and you add, you will get the displacement. Okay, so we are going to answer that question. We can do it here. It's quite simple. So the first one here, let's calculate the area of the triangle first. So let's say area of the triangle, and that is going to be equal to a half base times height. Okay, now which one is the base? The base is going to be this side here, which is 20. So the area is equal to 20 half. Let's write, almost forget that one. Is half 20 multiplied by the height, which is from there to here. So be careful. This one here is the height. So it's 2 to 4, 4 to 6. So it's 2 and 4 multiplied by 4. Be careful with that one there. Okay, it's 4. So this area is going to be equal to 40. So this one is 40 meters. Remember, we're calculating area, but area is going to be the displacement. Now, the second one, let's do it here on this side. The area of the right angle is equal to base times height. And then if we go them, the right angle, we have the base. Now for this one, the base is also 20 and the height is only 2. So it's 20 times 2. 20 times 2 is 40 meters. And then the final answer, the displacement, is going to be equal to the area of the figure, which is going to be equal to 80 meters, and then it's a positive direction, so it's going to be west. Guys, sorry, east. East is the positive direction. Sorry about that. So this is the answer of the question, and this we use the graph, and we did not have to use equation of motion or formula. It's quite simple. Let's go to the next question. I hope you understand. Now, to practice, I will recommend you to do all the areas of the graph, and you will get the final answer for the total displacement. Now remember, if you do that one to practice, this one will give you -1, so at the end you will have to subtract for e. Okay, but you try it. Now, question 7.4, after some time the object stops, turn around and move in the opposite direction, which in this case is what? How long was the object at rest? Now, at rest the object was when it is in the graph is right on the x-axis. In other words, this here is the time that the object was at rest, and that time is going to be 10 seconds. 10 seconds, I'm going to write here at rest. So 10 seconds at rest. That is the equation or the answer for question, let me see, 7.4.1. 7.4.1. Okay, and the final one is at what time exactly the objects turn around. The objects turn around when it was at 100, and they say at what time exactly. So the object turn around exactly after 100 seconds. So let's just write it here. There is no much more space. They write here after 100 seconds. That is the answer. And guys, this is the question. I hope it helped. It's a very good question for the upcoming exams at the end of the year. Please, you can write comments, subscribe for the channel, thumb up. I'll see you next time. Mr. G here.